This is a quick overview of the setup with very little explanation. This is what I believe to be a better way of testing our primary support point, whether it be a cinch canopy anchor or whether it be a basal anchor. What I have right now is a base anchor, and it also doesn't matter whether your base anchor is set at the tree or whether it's set an adjacent tree, or if you're doing a canopy anchor and you're going up a redirect or for a distance away from where your primary tree is. It's all set up the same way, and it's set up so that it doubles the load that you're going to be applying to the tree when you go up on your climb. And I trust a tested double load a lot better than any kind of a bounce check I can do, because I know what it is, I know how much it is. And when I do climb the tree, I know that I'm only applying about another 15%. So I'm testing it to twice, and when I apply my own load, I'm only going about 15% more. So here's the setup. This is my CE lanyard. All I've done is I passed the line through the thimble on the press-it cord, tied it off with a figure 8. That gets tied off to a loop, and then I come up and I use a pulley. Right now I have a hitch climber pulley on there, but I can easily use what I normally climb with is my revolver, Petzl's new rolling carabiner and those things. So when I step down on this to test it, I'm putting a doubled load at the anchor. Now it doesn't matter again if it's canopy or base anchor. If it's a canopy anchor, it's double. If it's a basal anchor, it's a doubled. So I stand on this, I sit quietly, and I listen, and I know that my load is doubled. Some of you might be concerned that, hey, if you pull down on that and you slide your press-it up the line, then you're not going to be able to reach it. And it doesn't really matter because you're climbing that line anyway. That's my climbing line, goes up the tree. I normally have my zigzag on the tail or a doubled rope system on the tail. So that is a quick overview for those of you that like to get the whole story in less than a minute. All right, I've started to kind of question the way that we do a stress test on our canopy or base anchors, actually the anchor in the tree. In this case, this is a typical method of setting up a basal anchor. Down here, however you do it, I've got a base anchor around the tree I'm in or adjacent tree. I'm just using a alpine butterfly, but however you set up your base anchor isn't the point. In this case, I put an alpine butterfly on here, and as I go into the explanation, it could be an alpine butterfly. Sometimes guys like these in here for rescue, but it could also be any kind of a press-it on the line. So the alpine butterfly goes there. My line comes up and over on the base anchor. What typically we do is we set our anchor, and then to test it, we'll get on this line and guys will do a bounce check. And my thinking is that a bounce check might induce some cycles that contribute when you talk about cycles to failure. In other words, I do a bounce check on here, and we demonstrated doing a bounce check. My load, my 200 pounds, depending on the friction here, will be doubled at this anchor. And you do a bounce check, and it doesn't go much more than what that double is, depending on how you do your bounce. Plus, when you're bouncing, you can't really see what's going on with your anchor. You can't hear what's going on with your anchor. And it's a momentary stress. So maybe you do 5 bounces on here for a bounce check, and everything seems like it's holding pretty well. And a bounce check is great for pulling out some dead wood and pulling out some small branches and setting your line. But say you do a bunch of bounce checks, it ends up being 5 bounces. Maybe this anchor here is going to fail at 20 bounces. So a guy will get on here and he'll do a sit stand. You see this a lot, guys climbing a big tall tree and they're doing their sit stand. Their rope is kind of stretchy and you see them, it's almost like doing a bounce check. What if this thing is going to fail at 20 cycles to failure? You bounce checked it to 5, but on your way up, you've induced all those other bounces, and all of a sudden it reaches 20 cycles to failure and your anchor breaks out. So here's my thinking with perhaps another way to do this. And it kind of came from a discussion we had on a rope test website. Richard Delaney was talking about it. He put a wrench across here, and I actually misidentified the mechanical advantage at first, and then when I started looking at it, that wrench disguised as a pulley made me misidentify the fact it was a Spanish Burton. A Spanish Burton is kind of a weird or interesting complex system, and I'm going to set this up just using, and all of this that I'm doing right now really doesn't use much more gear. It uses what I have on my saddle all the time anyway. And I'll explain this, not to get real technical, but I'll explain this so that we understand what the mechanical advantages are. This is a Spanish Burton. If that's my load, I've put a 3-to-1 down here and a 4-to-1 up here. But let's stick with the Spanish Burton for right now. And let's say that this is where my anchor is, and that's my load, and I'm trying to lift this load with the Spanish Burton. It's a complex pulley system. This looks like it would be a compound pulley system, but it is not. And the way that I know that is by counting the tensions. If I have 100 pounds here, that means I have 100 pounds here. That puts 200 pounds here, which means I have 200 pounds here. But I also have this 100 pounds on this side. So now I've got 300 pounds pulling up on my load. So that's a 3-to-1 mechanical advantage down there. Now let's switch the load and the anchor. Let's make that our anchor, as we're going to do in our climbing system, and make this kind of our load. It becomes a compound 4-to-1 mechanical advantage. And we can verify that by, again, counting the tensions. I have 100 pounds here, puts 100 pounds here, which means I've got 200 pounds right here. If I have 200 pounds here, and this is a pulley, again, we're ignoring whatever friction would be on here. If I have 200 pounds here, it means I have 200 pounds here. Since I pulled 100 pounds, that's a 4-to-1. So let's use that 4-to-1 to check our anchors. The way that I do that is I just set this up. All I've done is put my tail of my lanyard through that alpine butterfly. And now instead of standing on my climbing line, I'm either going to foot lock or I'm going to stand on this side of my line. And as we did our tests outdoors, and I'll show that in this video towards the end, I take my 200 pounds and all of a sudden my 200 pounds becomes almost 800 pounds up here at the anchor, depending again on what kind of a friction I'm looking at. I replaced this DMM revolver with a hitch climber pulley. I put a friction a pulley up here, and so you can get varying amounts of quadrupling the load, but the point is that you have greatly increased the load, and you've done it statically, in that it increases the load and then it stays there. So while you're hanging on this and you've got almost 800 pounds on your anchor, you can have a ground person that's standing off to the side. He's watching your anchor. You can stand there and listen to your anchor and have some stillness and have a sense of what's going on with that anchor with that greatly induced load, and know that it's secure. And then when you've verified your anchor, then you can remove your mechanical advantage and climb up your line, knowing that you've given that a great stress test, and you know it passed the stress test. You didn't see it crack or hear it crack or move. And I think it's a better way to actually do a check of your canopy anchor. Now we'll go into how to set this up if it's a canopy anchor rather than a base anchor. The importance of this, I put this greatly induced stress test on the anchor, but when I go up and I do it in a rope walking manner, I may have 400 pounds on here, but as we demonstrated with the load cell, when I walk up this rope and I'm not taking huge steps, I'm just taking comfortable steps, I only add about 15% to the load. In our tests, it went from 400 to 460 pounds as I was walking up the rope. That's important because now I'm only putting 460 pounds on here, and I tested it to almost 800 pounds. Big difference between what I tested it at and what I'm actually using it at. All right, this is a setup like you were using a canopy anchor. All I've done, you could use the tail of your climbing line, you can use whatever. I just grabbed a friction saver. I wouldn't use that because how the rings on the carabiner and such. But what you want to do is you want to get an anchor to the base of your tree. And then the same thing, you're going to come up with a pressic or the hand ascender. I put a hitch climber pulley on here. And now again, I'm going to hang from this part of my line. When I do that, it's going to double the load that I'm going to use when I climb. So when I do this, I'm going to test this anchor to about 400 pounds, and then when I climb the line, this all comes off, and my lanyard goes with me. When I climb this line, I'm only going to be putting 200 to maybe 230 pounds with a rope walker, so I'm only increasing the load maybe 15%, but when I test it, I'm increasing the load double. And I'm listening to it, I'm watching it, and I'm hearing it, and I'm making sure that nothing is failing. And then I know from the difference of 200% to the 100% plus just a little bit from the rope walking makes me feel a lot more secure and comfortable about the anchor that I'm using.
Judy's up at the tree and she's looking at the enforcer. Got the video camera on that. She's looking at the enforcer and she's going to measure the forces. This is a base anchor, so depending on the friction, we would see double my load. I'm 200 pounds with my gear, and so we're looking for about 400 pounds when I get on this line. Now, normally I'll do a foot lock on there and do the bounce check and stuff, and again, I'm just thinking maybe that's not a great way to do a anchor check. And so just for convenience right now, I'm going to hold on to the Kong hand ascender, put my foot ascender on there. Again, I wouldn't do this in real deal because if you shake something out of the tree, you want to be in a position where you can kind of pull loose. Definitely don't have your harness hooked up. Maybe a foot ascender, I can run with a bit of rope on my foot. But anyway, so I'm going to stand on this and we'll see. We would expect Judy to have a load of about 400 pounds up there once I load this anchor, and she's going to read to me what that is once I get hanging. All right, I'm pretty much on that load. What do we have, Judy? 420. Well, that was after a heavy lunch. Okay, so all right, let's go with 408. All right, I'm coming off, and so now that was 400 pounds of sustained load, and that was what I'm going to put on there. So here's my base anchor, and as many of you do, you'll put a alpine butterfly in there for a rescue. So I'm just using that, and then basically taking my lanyard and my hand ascender that always goes with me, and I'm going to push that up so that I get a little distance. Now I'm going to stand on the lanyard, and that's going to put a sustained double load at my anchor. Plus, if I stop talking, you can hear the anchor and you can know if there's any cracking, any bending, any movement on that anchor. You can sit there quietly and get a real good sense of what's going on with that anchor. Then, once I've checked the anchor, then I'll do my rope walk. I won't sit stand, I won't do any hip thrusting. Nothing that's gonna do a bounce that you don't know what the cycles to failure will be. So right now, I'm gonna stand on this and Judy will tell us what the reading is. All right. There I'm pretty much on there and I can quietly listen to the anchor and watch it.
It's about 668, 65.
665. All right. Very good. Now, what I'll do is swap out. I'm going to swap out this revolver. We'll put a little more efficient pulley on there. All right, so now I'm going to swap this out for a more efficient hitch climber pulley, and we'll see what that number is. All right, you ready, Judy?
I'm ready.
All right, here we go. What's our reading now?
It's fluctuating. Well, it's about 190 to 100.
Okay. All right, I'm gonna start putting my weight on it. And that's about all of my weight. What are we reading now?
About 750, 760,
760?
770. It fluctuates between 750, 770.
Okay, so we're getting up to about 770. So there we go with about
780 a little bit too.
780. So we're seeing about a doubled load. And now that I've sat here and I've tested it for a sustained load, I'm not seeing or hearing any movement in that anchor. Now I would feel very comfortable to go ahead and go up this on a rope walking system where I didn't induce any more than just my doubled load. So I've tested everything to almost double what I'm going to be applying to the anchor. I'm going to go ahead and take this off, and what I'd like to do now is just do a bounce test like you would normally do, and tell me what kind of a number we see on a normal foot locking bounce check. Okay?
Okay.
You ready?
Okay.
Okay. So the first thing I'll do is a standard bounce check, and we'll see what kind of numbers we get. All right, so I weigh about 200 pounds, and we'll see maybe 400 pounds or more up there at the anchor. What are you displaying right now?
Right now I'm pulling 6, 9, 7, 13,
16 pounds?
18.
Okay. All right, so now I'm going to stand on this with my foot ascender, which we don't normally do, but I want to get a nice consistent load at that anchor. And there's just standing on it. What is my load now?
About 400.
400 pounds, which makes sense if I weigh 200 pounds. Now I'm going to put a bounce on this and we'll see what it goes to. Normally I would do this with a foot lock, but all right, you ready? All right, so I'm bouncing on this. What kind of a number do we see now?
It went up to 641.
Okay.
That's number. It went up between 3 and 600.
All right, so 300 to 600 pounds. All right, so now what we're going to do is we're going to take and put a hand ascender on our ascent line. And oftentimes I'll run this with a DMM revolver, but right now we're going to try to get as much load as we can put on that. And now I'll stand on the lanyard side, which is going to make a compound pulley and double the doubled load. So I'll see something in the vicinity close to 800 pounds, and I won't bounce on it. We'll just see what kind of a sustained load it is. You ready? That's me standing on it. What kind of numbers do we see now?
760, 775.
775, pretty close to 800. And I can sit here and I can watch the anchor, I can listen to it. It gives me a really good way to see that it's going to sustain that load. All right, I've come off of that. Now, just for fun, I'm going to rope walk up that line, and let's see what kind of loads we get with that, okay? All right, and you've had a pretty good reading on the, is that graph starting to disappear? Anyway, you had a good reading on that, so yeah, that'll be good. Okay, so now just start focusing on the numbers, and I'm going to hook up my rope walker, and we'll see. When I first hung on it, it should be around 400 pounds. I'm coming onto the rope right now, and the numbers will start up. Okay, now I'm going to hook up my rope walker. All right, what are we reading right now? And just start giving me the readouts. 415, 437, 468. What are we at now?
It's between 400 and 460.
400 and 460?
444, 369,
All right, so that's
395, 430.
all I did is walk up, and it went from about 400 to 460 maybe, right? All right. So I only added 60 pounds to that load.